Yeah, welcome everyone for cloud computing and big data, parallel and scalable machine learning and deep learning. Today is our prologue lecture, so sort of an informal lecture that shows you a little bit on the 10,000 feet perspective what this course entails, and usually also clarifies a lot of questions you might have. Questions like assignments, what is the final project about, or how we can do groups in those assignments. So many of these questions will be today addressed, and of course also the content of the course will be a little bit structurally presented, and we will also give you a couple of hints where you can expect assignments and so on. Before I start, you see also there's quite a lot of logos here. That means this course is also part of larger European projects. You see here the RACE project, for instance, or the EuroCC2 project with the Icelandic National Competence Center for HPC and AI in Iceland. So these are all European initiatives, and it's clear that that's not, clear to all of you here in the room, but you will see every now and then in the lectures, I will actually make a point why we have these logos here, and also will include materials out of these projects into our lecture series. So we brought together here a quite nice syllabus for you. We have quite some experience in teaching this course now over the last 10 years. And of course, cloud computing evolved, right? So that's why you see here and there, even if I told you earlier in the other lectures that before you have YouTube lectures, you could look in from 2021, for instance, or 2022 as a preparation of this course, you will see some changes. And however, many of the, let's say, principles and paradigms will remain, paradigms like MapReduce and so on. So I will talk about it. And when we go through the outline of the course, you will notice that we have some practical topics here in green and some in blue. And they rather stand for the ideas of bringing you the practical topics earlier in the course. So normally we would start with quite some, let's say, lecture series really on conceptual topics, but experience told us from the past that we should integrate, you see this, for instance, here very early in the course, already something where you can work with assignments. So then we will break here maybe the complete normal idea of bringing you across cloud computing in order to start the assignments early, which was mostly appreciated by students over the last 10 years. So starting from the beginning, after this prologue lecture, which is more administrative in a way, we dive a bit more deeper into cloud computing and big data, really an introductional lecture we will have there and clarify many of the elements and many of the terminologies really inside the course. Then we have machine learning models in clouds. This stands already for a practical element, so where we will really talk about one cloud provider here in the course that we can use with Apache Spark to really work on machine learning models. Who has used machine learning in the past? Okay, a couple of you. Yeah, very good. Here, of course, we don't have a machine learning course, right? That means we learn several fundamentals of machine learning and we'll use them in cloud computing, but the deep down details of machine learning, statistical learning theory, Höfting's inequality, the feasibility of learning, etc., etc. All of these important aspects, validation, or maybe also different regularization techniques, etc., etc. These have to be taught in other courses. Right, and I would encourage you to do so. For instance, Stain has a machine learning course here, very fruitful to be complementary to this cloud course, really. However, to give you something concrete, where actually lots of applications these days are derived from big data, is machine learning and deep learning. So we start with a nice introduction, then lecture 2 and 3 here, of showing you how machine learning can be done with Apache Spark in clouds. And then we also formulate one assignment around that. Having done this, and while you're busy with the assignment, we come back to some conceptual topic, because many of you will ask, what is now the data center design that can hold or accumulate so much big data? Virtualization plays a big role there also, because we have many users which are geographically dispersed across many different regions, and they all want to use a data center at the same time. Hence, the load of the data center in terms of computing, but also in terms of storage needs, needs to be understood for a multi-user environment, and virtualization can really help there a lot. And to really give out the assignments early, you see that we insert, again, after this conceptual lecture already, a new sort of practical lecture series here, which is starting with a map-reduced computing paradigm. MapReduce is something you may all know from, who has heard from MapReduce before? Okay, a few. So who have heard from divide and conquer? Okay, yeah. So divide and conquer is, of course, principles of computer science, right? And MapReduce, you will see, is basically very close to it, and will also give you an order of understanding how you can practically implement this within clouds. To have one, let's say, killer application today in cloud computing with big data, we also insert in the course a little bit of deep learning the last couple of years. The reasoning is that, of course, many jobs related to cloud computing in this area with big data are actually in the realm of deep learning models, learning them. We will talk about in the second part today also a bit more what deep learning now contrasts to machine learning and elements like this. But this will be next assignment, so to speak, assignment 2, that you will work on while you're busy with this. We also have to capture some terminologies, and these are quite, let's say, terminologies that stand the test of time. So who has heard from infrastructure as a service, platform as a service, or software as a service? Okay. So these are terminologies where the boundary between them is actually not that strong anymore. I think they sort of partly overlap each other, but still have a meaning. And we will explore this in this 3 conceptual lecture, really to understand a little bit the different, let's say, fundamental idea behind it. As the name suggests, IAAS is mostly infrastructures, so computing, VMs, and so on. Platforms already have Lego building blocks to create some applications, and software as a service really means the application is ready to run. You can swipe the credit card and usually get going without any implementation, without any programming. So, however, many people have today invented really STAR AAS, which stands for basically everything as a service. So we will also come in these lectures to the point to understand that these boundaries are a little bit, let's say, artificial, and of course, all of them have to work together to really create applications in clouds, and we will make the case for it. Then the last assignment before diving into your final project will be then around big data analytics, cloud data mining, a little bit about also understanding hyperparameters, optimization techniques, and AutoML techniques. So you see 11, 12, and 13 are again more practical in the sense that they will be related to your assignment. And big data analytics is a little bit different from directly machine learning. They overlap in many facets, but still it's a different topic, and we will talk about this when we introduce some data mining algorithms, like looking, for instance, at shopping data or so. And then Docker and container management basically is an application topic, which is very important for managing clouds, however, right? So you can perform in cloud computing many activities with so-called containerized applications, and they're very famous in data science as well. And the underlying technologies like Docker or Aptena we will introduce here in the course, also touching a little bit on Mesos and Kubernetes with kubelets, if some of you will know, and basically think a little bit about, again, the application management in clouds. And those techniques are also supported by AWS, by MS Azure, by the Google Cloud. So there are many cloud providers in the public we will talk about throughout all these lectures. Then you see here quite nicely, hopefully, the new sign to also show you that we don't use every time the material from the previous years. We always try to inject here some, let's say, new materials. And one of them that has gained some momentum in the last couple of years is really the hyperparameter optimization. So hyperparameters means everything related to deep learning models or architectures, really, where you decide about parameters on how many layers a neural network would have, how many neurons are in that layer, how many basically different sliding windows you have. And then there are some other parameters which are more towards the optimizers that are actually used to learning these deep learning models. And those can be, so for instance, a learning rate, or exactly the optimization technique. Is it a stochastic gradient descent, or maybe some other techniques? So this means by optimizing these hyperparameters, the performance of the deep learning model can be most likely improved. The same is actually true also for machine learning models, but for deep learning models, is that even more interesting here for the course, because it requires a lot of computation. A lot of computational capacity goes into the systematic and automatic optimization, hence also the term AutoML, which is a little bit broader because you also can see that deep learning has a lot of models, right? It has models for time series analysis. It has models for computer vision. And even within computer vision, you would say it has tons of algorithm transformer models, autoencoders, with encoder-decoder structures that all needs to parameterized. And to find these parameters, people use that usually manually. And with this, it's of course not optimal. Although some people maybe gain some experience over time, still this hyperparameter optimization AutoML have some systematic techniques we will talk about. Then as a sort of end to the course, while you're busy with this third assignment, we talk about OpenStack. OpenStack switches the perspective a little bit away from AWS, MS Azure, Google Cloud, and so on, to rather think about what happens if your boss steps in your office and would say, please create the own cloud for our own company, right? So an OpenStack would give you all the building blocks really you need to do that. So it's an open source software stack which enables you to create an in-house cloud. And hence people call it sometimes even a cloud operating system, because this is something which is quite nice, quite flexible, and prevents you from re-implementing the wheel, right? To create another, let's say, EC2 computing sort of software that manages the, let's say, scalability up and down. And scalability is a loaded term we have to talk more about in a couple of minutes, because this is also something where cloud computing gets its name from. Then, towards the end of the course, we could have a complete lecture on it. Graph databases, graph neural networks, what happens with online social networking. So all of these are inherently data structures which are not so structured like the SQL-based databases you may have heard from the structured query language. Everybody has a name, everybody has an address, etc. But the nature of the data is very wild, right? And it's very interconnected. If you think about Facebook, who likes who, and who is basically following who, etc., etc. The epilogue is then more on the, let's say, informal aspects again of the course, closing the course, also reviewing some job matters. We will dive into each of these lectures in the second part of this prologue, even more, so that you understand a bit more what I really talk about. I just wanted to give you here a sneak preview now about the structure of the course and how it's really is implemented with the assignments. So, of course, there are some practical lectures included here and there to these blocks. So these are just the main conceptual slides. There will be some practical lectures, as you have probably also seen in basically 2021 and 2022. So let's come a little bit to the course motivation and information. So the course motivation is really that cloud computing uses a lot of distributed computing, a lot of parallel processing to manage the load of big data. And this is a traditional field of computer science. It has been really well developed over the past, coming from grid computing, the technique basically before of dealing with big data and distributed computing, to a really mature area we call today cloud computing. And the course really tries to have a comprehensive approach on this. So we don't really focus, let's say, just on AWS services and Amazon and show you everything there that you get a certified AWS programmer. We rather think about having different layers, computing theories and technologies, but also think a little bit about programming and actually also applications of these cloud systems. And we bring the case for it every now and then. You have seen it with machine learning, but also then how to do it with Docker and applications, how to do it then with data mining and applications. And these are all approaches to really have applications on big data, and with this also solve big data issues. Of course, needless to say, some of you have been in part of my other course, High Performance Computing. The course has directly and indirectly many links to the High Performance Computing course. Let's say GPUs, for instance, are also available in the clouds, graphical processing units which accelerate deep learning significantly. Hence, with this, we also try to have latest advances in the course. What could that mean is, for instance, that we also talk about the Hopper GPU, for instance. It is one of the most cutting edge from NVIDIA right now existing, and has a long, let's say, track record of previous architectures, really. So there was Pascal, there was Volta, there was Ampere, and now we have the Hopper architecture of GPU. So this is something where a lot of, let's say, new technologies are also in the course and have quite some speed in terms of technology developments. And you will see that the commercial clouds also integrate this, where we also have to have, of course, a view then on this latest advances on prices. You can imagine if you want to have an old GPU, the cost will be relatively moderate. But if you want to really go to commercial clouds like AWS again or MS Azure and want to have the cutting edge Grace Hopper GPU with lots of memory, you can imagine you pay a lot of money. And this needs to be incorporated in the price schemes of all the different cloud services provided by, for instance, SME or by other industrial players. Hence, we will talk about this. And with this course, you also have some basic knowledge really how to tackle parallel and scalable machine learning problems, which is a quite popular, let's say, job today. So many people search for these experts, which not only have machine learning expertise, but also know how to scale this up to many users, to big data, and perform this in parallel with clouds or HPC. And of course, the topic of deep learning is really something where we will see there are lots of jobs around today, because it's a huge area where I believe even you could say that deep learning could be a complete professorship, right? So you would say there are so many deep learning models, which is crazy to have an overview. Even as one person alone to say, I know all the deep learning models is already quite a stretch, right? It's really an interesting field that has been now creating numerous advances in science. And we will see also in a later video the breakthroughs, and of course all over the course as well. Hence the chances are, and that's why we do this, that you get good jobs after this course, or at least after you're studying when you had this course. Every now and then we also think about science and engineering in terms of more academic endeavors. You will see here the European Open Science Cloud, for instance, for those here in the course. I know some of you are maybe PhDing or doing, master level research. So this is something where, of course, also activities in the clouds are not only in the commercial areas, but also at the academics. And as one specific facet, you see also new a little bit, we try to cooperate more and more with local Icelandic cloud providers. And there are many of them. So Advania has clouds. We have Responsible Compute with clouds, Borealis data centers. They all try to have some, let's say, new cloud-based approaches to the data centers here in Iceland, which makes them also very green, right? And we will talk about this when we talk about data centers design. So a very, let's say, structured idea of a course, very practically oriented, as you see with the applications. And when you have done this course, you should be knowing what parallel processing is, and especially also distributed computing, particularly here in cloud systems. But the general understanding will also help you to understand high performance computing clusters. And then, of course, the other side, we will discuss how you leverage this, right? So these are hardware systems nicely available in cloud systems, but how you really want to use it means, techniques, for instance, using machine learning, deep learning, data mining. And then a little bit of other aspects like how actually the big data center then is able to scale, and how you, of course, perform an automated computing, for instance, hosting a billing service that is important for your app, that you basically want to not, babysit all over the night. And also, if you think about that big data centers, then as a figure here is suggesting, also are able to scale up or maybe also scale down, depending on the load. This should be sort of automatic, right? So you don't want to have this always babysitting again and say, oh, there's lots of peak users now for some reason, maybe vacation, and many people actually play our game. So this is something which also have, many services in the clouds in the course inherent. So here and there, we also discuss then the transformation that you have from a, let's say, normal HPC sort of cluster or multiprocessors or laptops and so on, to these large data centers. So where are the big differences, right? How you deal with this. And yeah, you would able then to really use machine and deep learning tools in the clouds, at least selected ones. For instance, like SageMaker, we will look a little bit on this, or AutoGluon, all machine learning, deep learning tools in clouds, for instance, from AWS, but we also look at MS Azure, HD Insight, basically Hadoop and Spark-based approaches. So you can also then perform big data mining on clouds and work with big data. And this is, of course, one key focus here of the course. So a very comprehensive program. And now you would ask, why could I teach all of this? You maybe just have here one short slide basically about myself. I did my PhD in Karlsruhe as a cooperation very closely with the Jülich Supercomputing Center, where I'm still having a research group since 20 years, actually. And we are very closely collaborating with Iceland. So that's also bring me here to the professorship, which I got, let's say, 10 years ago, which is since then a very fruitful and growing, let's say, environment for many PhDs. You see in the acknowledged slide at the end of the course. So we had very strong collaborations with Germany and continue to do so. And I touched on these big data topics and cloud computing topics combined with high performance computing since 20 years. So it was always big data. You see, I was working with CERN, the Large Hadron Collider. If you remember, this was one of the important ingredients to find the Higgs boson in physics. I was a strategic director of all the middleware developments. I also was very much in touch with the US, actually contributing to the large infrastructure of HPC and cloud computing called Exceed in the States, funded by the NSF, the NSF, National Science Foundation. And then many of different European projects. I have also, let's say, touched upon all of these topics that I basically teach in this course, right? There was a European data infrastructure, research data lines, big data analytics chair, deepest, and so on. Maybe one of the highlights is also that I'm here, the European EuroHPC Joint Undertaking Governing Board member for Iceland. You don't know what that means right now, but we will come how that materializes throughout all the course materials. Needless to say, I'm teaching since 10 years here, very different courses among also, of course, of all these subjects. But of course, also in my previous life before the professor, I did already many trainings in the area of this course materials at the Jülich Supercomputing Center, or basically invited at Barcelona Supercomputing Center and many others in Europe. So stop this self-marketing. I just want to explain you a little bit why Jülich Supercomputing Center is also for the course a little bit an important part, because we will use resources from the center. And you see here my other base, so to speak, apart from Iceland. This is in Germany. It's one of the largest national research centers in the Helmholtz Association, which is basically a large association for research here in Germany, around 5,000 employers. And you see here, our supercomputing center is just a small fraction for it, but serving the needs not only about all in Jülich here, but all the Helmholtz organization you see here. And we are also very proudly now the host of the first European exascale computer that we will see, and basically from February or from April next year. So that is also sort of a kind of ID card of saying, this is one center that in the last 20 years have been to become one of the most important centers in whole Europe. And this is something, of course, where many resources are and that we will also leverage. A little bit to the University of Iceland, back into our collaboration. You have seen in Times Higher Education, we are one of the top universities, for instance, in remote sensing. Hence, we have also special labs there in context of HPC and cloud computing. We have many foreign students who will also actually realize this. And we are also the coordinator of the Icelandic National Competence Center for HPC and AI, which is actually a EuroHPC activity under the EuroCC 1 and EuroCC 2 projects. And hence, there will be an important element in the course every now and then from this National Competence Center. One will be happening tomorrow evening, where we invite you to participate in our eHPC workshop, and we'll get actually 5 bonus points for our final project in the course. Hence, we talk a little bit about it. This European Joint Undertaking is actually an initiative to to really focus on HPC, and this includes also partly cloud computing resources and cloud computing approaches, or those that fuel clouds really. We have there lots of EU projects, which also then are some of the logos you have seen, in which context we also teach this course or make this course publicly available on YouTube. We have participated in the European Open Science Cloud, where we have also a little bit of lecture material on showing you how actually also academics can use the cloud. And you see here on the right-hand side a little bit our Icelandic community that is structured across different, let's say, capabilities and competences really in different areas of science and engineering. So a more different view on this is maybe this interesting slide, where you see behind each of these different initiatives and labs here are many people in Iceland that are experts in the field of this respective area. And of course, it's an invitation to collaborate with us, right? You have here the website, ihpc.is, the National Competence Center, and you see much more information, who is behind these labs and so on. And of course, we see several industry collaborations also emerging here. You see, for instance, our acoustic and tactile engineering lab, we have strong collaboration with Treble, an acoustic company here in Iceland, but also for the natural language processing lab, we collaborate closely with Methane, that also like to work with us. You see a small testimonial here. So hence in Iceland there's also lots of things in this area happening. And this also shows the power of the clouds. We may not have the biggest HPC centers. We have lots of data centers, however, but we can still work remotely from Iceland with many of the people worldwide. And you see here one example how that is very fruitful. The Data Lab Remote Sensing, steered by Jon Atli Benediktsson, our rector, but also by Professor Gabriele Cavallaro here, a new professor just hired here as tenured professor recently. So this is steering really lots of activities with lots of PhD students, and also reaching to the fact in the end that basically remote sensing is still in the University of Iceland, in the rankings of universities, really an important subject. So we will have also several examples of remote sensing, because many of the gentlemen you see here on the pictures have used HPC and cloud computing resources in order of magnitudes of scale. And because it's also relevant for the course, you can see here on the right-hand side, the satellites, they are generating big data, right? Lots of big data, and hence the deep learning models that you use and machine learning models have to deal with them. Hence, you cannot just use your little laptop anymore. You have to go to cloud computing resources, you have to go to HPC resources, and we will talk about throughout the course. So let's think still about terminologies a little bit before we continue more to the administrative elements of the course. So we have this big field called artificial intelligence. Who has heard from artificial intelligence before? Okay. Who has learned about machine learning already? Yeah, deep learning. Okay, so many of you here and there touched across this, but don't worry, we keep it also to a moderate degree here in the course. Mostly you can actually categorize these, let's say, algorithms or the goals of the applications into the right elements you see here. Some want to do classification of data, clustering of data, regression techniques, so finding trends here, or clustering of basically data points which seem to be very close to each other or very similar. Or when you have a new data point, you want to categorize, is it class A or class B? So machine learning is essentially a subtopic of artificial intelligence, where deep learning is then even more specialized in machine learning, really. So let's have a look a little bit also how this then relates to big data. You see here that this is an area where you would say some pattern exists in the data, and you have no mathematical formula to work on this. So basically you learn from data, as we call it. And of course, in this course, we think about learning from big data, so which is really scalable. And many of the algorithms in this area are really overlapping with the data mining, machine learning, or statistics. And in the recent years, there was a terminology called data science coming out, especially in the area where you use more and more computing techniques, right? Things like Apache Spark again, Apache Hadoop for MapReduce, or on the other hand of the scale, also HPC with parallel and scalable machine learning and deep learning techniques. So Hence, these are challenges with the big data we will talk about. And one good idea to understand now differences between machine learning and deep learning, but also a little bit about the computational complexity, is exactly this idea here of the video, where we see neural networks, and all these neurons are quite interconnected with each other. You see here a standard neural network, and let's say more elaborate one with 2 hidden layers. That's what we did in machine learning. And you did some features out of this, which you basically have manually created to learn a model. This is more the traditional machine learning type. So in deep learning, we changed this to learn features more via the modeling. And as the name suggests, you would say it's deeper than those you see here. So you put more and more, let's say, connections in. Here is still just the perceptron. So just actually everything is connected here to recognize number. And remember, we will have deep learning lectures, right, where you understand this a little bit better. But here you see the multi-layer perceptron in the video now, which already introduces now these interesting layers that you have also here up there. There's 2 hidden layers, for instance, and then one combining layer that then gives them the rise to the probabilities of the classes. However, deep learning is not, and this will be coming now in the video, the idea of just adding more and more hidden layers. That's not the idea of deep learning, although the name suggests that in a way. And of course, partly it's true that we add more and more layers. But the key message to take away is that you have really specialized layers. You see that here in the nice video on the convolutional layers. You see they have this interesting feature maps that recognize numbers in different types of writing styles, and then it will actually then also be able to, as you basically see here a little bit on the conceptual figure, sample out of this, perform another convolution operation. This is all not obvious directly to you, and we will talk, of course, in 1 or 2 lectures very deeply about it. But this was key to success, for instance, doing image recognition of partly, faces which are not fully there, for instance, just based on these features. So spiking neural networks are something for the future and also not tackled by the course. I stopped the video here, but take away the message that we will talk about why these layers then are also so massively computationally expensive, and why deep learning also needs a lot of deep learning power in terms of storage and modeling data. So this is a loaded topic. It needs lots of data in to do proper modeling out. You can see this a little bit here, where I'd had the good fortune to inform our Bundestag, the German federal parliament once, and they gave me the task of saying, you have just 1 slide where you basically say the relationships between machine learning, deep learning, please, and HPC and clouds and big data. So this is sort of this idea that you have the dataset volume on the bottom, the statistical learning techniques, the traditional learning models we have, which work well when you have small orders of magnitudes of data, but they quickly have a problem with the tools when you basically come to big data. So the memory mostly, or the computing capacity, is not good. So you have to go more and more to computing as far as you basically want to increase then your model performance. And usually have small neural networks already need more computing. When you then have medium or even large deep learning networks, you talk about lots of computing time in terms of training these models. Hence, computing plays a big footprint here. And still the trouble is that even in deep learning, if you don't have, let's say, big data, you have small data sets, you can forget about this accuracy and you're rather here, right? Then the ordering that the large deep learning model will probably have the best accuracy or performance will not hold, right? And it's only working when you're swimming in data and big data. And we will talk about this in the course as well. This just gives you hopefully, and I got actually good feedback on this, a good view how the course here will tackle this. Understanding deep learning a little bit from the big data momentum startup example here. There was lots of work over the years that contributed to the big impacts we have now in deep convolutional networks. I think that's sort of understood in science. And there were kind of 3 ingredients that are very good. Big data, as I said, the large data sets, which have become also publicly available. The hardware, more and more GPUs really, that tackle the kind of computational complexity. And then software, really open source tools, not reinventing the wheel of creating the next framework for deep learning. There are very many now publicly available. And you see here one example out of my research group, the Exist idea that was then leading to Soccer Watch TV, where you have then basically automated computing, analyzing with deep learning techniques really these players on the field and where the camera should have the focus. And I'm bringing you all the references always in the bibliography, and you can of course look that later. They today even have actually started these days to expand this to basketball and other areas. So in the course we use then also for the assignments, coming back a little bit to what we do now in the course at the end, administratively, we will provide you, of course, here and there with real cloud services, but sometimes also here with the deep project done with some GPUs to do some machine learning. So hence, we will come also to the idea that everything, and you learned that already, I think, partly with all my messages on Canvas when the course starts, but also the material of the course, everything will be there in the Canvas tool. When you have questions or major difficulties, don't wait too long. Please book office hours, but don't knock on my office, right? I have my calendar basically every hour scheduled every single day. That means you have to talk to my assistant to book an appointment. And this is very important. Here you see the email. She is a lady called Sika. That then will schedule basically a particular date and time for you. So this is very important because, as I said, I'm quite busy, still a very active researcher. For the overall course organization, we touched upon this already when we went to the structure. So the 3 assignments around the practical topics we discussed. For this, you can create groups of 2 to 3 people, exceptionally maybe 4, but please 2 to 3, and send this group information, please, to my assistant. Very shortly now after this course, you have the chance to really, mingle maybe with a couple of them. But we have also the add tool coming up where you can then find group members. There will be a small set of quizzes to also understand a little bit more the conceptual ideas of the course, right? They will be pre-announced. They just have a minimal input to the grade, but shows that you at least understood some pieces of the course. And then there will be the final project. This is also a new change in this course. We didn't have the change last year because it was sabbaticals or no course. But now we basically learn from students, according to my lords and masters here in the universities, division leaders and so on. They say that the students in surveys say they want to have final projects. And so we will give you the final project here also in the course and don't have an exam. And we will talk about this later in the course, what this entails. Here and there will be also selected invited lectures from companies and so on. Also, some of my PhD students will present aspects where, of course, this will be a very hopefully lively course for you with lots of takeaway messages. Hence, again, saying, of course, the add, and also this would be possible to discuss around assignment questions, but also, of course, then the submission and everything and the quizzes that I alluded to, they will be all basically in Canvas, right? So Canvas will be the place to be to understand basically the submission, also all the course materials, modules, and the links to our YouTube lectures. Speaking of YouTube, this is something you already know from last week, where I told you, please have a look and, skoða a bit, as I would say here in Iceland, look a little bit on these courses. From 2021, 2022, many of the facets and paradigms will be still remain the same here in the course. Hence, you can already look maybe forward in the course if you have time. Here and there, we add some new elements, of course, or new lectures. But all what we do here in the course will be also usually recorded into this YouTube channel as a new playlist, of course. But let's say assignment questions, Q&A sessions we will have will be, of course, rather recorded internally for Panopto and not put on YouTube. So hence with social media, YouTube, we are also through our EU projects very much interconnected and present in social media. So we would encourage you to also talk about the course here in these different channels, like LinkedIn, for instance, is very strong in our field, but also Facebook, Instagram, and also here Twitter still a little bit, which is actually now X, as I understand it. So basically, this is something also where we're active. But focusing on LinkedIn might be also professionally quite a good idea. So I encourage also every one of you to think about a LinkedIn profile. Then usually questions come around literature, and this is a loaded topic. There are good books around, and from authors that I know very well, like Ian Foster. I was doing research project with him for many, many years. And Jack Dongara here. Geoffrey Fox, these are all big names in our community, which know a lot, which write good books. And I would say these 4 books are a good way to look at. But however, I would say it's much more useful to look through the lecture bibliography. You will notice that each of the different course hours we will have, the lectures we present will have always a substantial lecture bibliography with new links, with new book ideas. You know, cloud computing is a topic that reinvents itself every year. So writing a book about it is also very hard to keep it up to date, right? So in this sense, I would rather say follow the bibliography, don't buy big books, and also think about the YouTube links I bring at every end of the course hours. So we will see that now when I present you the one on deep learning. Every course will have, you know, 2 deep learning lectures also, where I encourage you to also think about others that teach about this topic, right? It not only should all come from me. Think about how others perceive several of these terms like infrastructure as a service and so on. So finally, just a small hint for next spring. For those of you who might be needing another course and have not done the HPC course yet, it has several overlaps with the cloud computing course, especially in the technical foundation. So what is a GPU, what is a CPU, what is memory, and so on, but also on different distributed computing techniques. Hence, I would encourage you, if you're interested, to maybe consider this course. It is a bit more on C programming. It's a bit more lower level, don't have this higher level service that we have in clouds, but we have quite nice domain specific science and engineering applications. You see here weather forecast, or let's say how basically smoke is propagating through tubes or car crashes and so on, all what you need basically to be an engineer. So an interesting course just for you as an appetizer for next spring. And finally, now there will be a video. This will be not anymore on YouTube. Hence, a YouTube video that is already on YouTube should not be shared again on YouTube. You can understand that, I guess. Hence, I would give you always this here as a little bit of homework to look at it. And we play the video, of course, now in the classroom, right? And then we will continue with the second part of the course after a short break.